Okay, everyone, we are recording, and I want to welcome you to a 3-day seminar, workshop, talk on NLP, NLP++, and the NLP++ compiler and interpreter. And it will be, today I'm going to be talking about the history of NLP and NLP++. Tomorrow, my colleague Amnon will be talking about NLP++ and how he wrote. He's the person responsible for writing the interpreter and actually parser for, or compiler. Actually, he does have a compiler for NLP++. So that's going to be an interesting talk. And then on Friday, we're going to be talking about actually using NLP++, places that has been used. So I really do hope you enjoy this talk. So we'll start out. Everybody seeing this? You seeing this, Amnon?
I'm seeing, yes.
Okay. So, well, here's the first shocker to you guys. You really haven't been taught NLP. You've been taught statistical methods. You've been taught how to use packages that are kind of already there, but no one's teaching it anymore. It's not taught in universities. It's really not used very much at all in industry. Now, you may dispute that because you're going to call statistical methods NLP, but that is something I'm going to talk about today. People like myself and Amnon, who have been through 4 decades and watched NLP grow, this is something that we really truly believe. These facts could shock you. NLP does not exist in universities and industry today. Almost everything you see is statistical. NLP, what we call NLP, is not a statistical or probabilistic in nature. I've got a degree in linguistics. I care about language and understand language, which kind of understands also knowledge. That means machine learning, neural networks, text vectors, and large language models I would not classify as NLP. There was a big argument at the Association for Computational Linguistics, which is the big computational NLP, if you want to call it, organization, worldwide organization, been around 60 some years. And people were saying, no, it's, large language models is NLP and AI. And sure, we can use language any way we want. But I think what we're trying to distinguish here is what we call the natural language processing, which is a very different beast. I'm going to turn off my video just to make sure the bandwidth's okay. All right, and today's program is NLP is just a set of tools you use in Python, just like Beautiful Soup. I've used Beautiful Soup, and that's what kind of people think it is. A lot of people think it is solved. Yet, when I talk with students, they almost all universally say this stuff really isn't useful. When they do your projects in school and you take a sentiment analyzer, which is basically a trained set, and you run it on and you make all these big claims and you talk about it. And then I asked one of the students that I saw do this at the my last job. And I said, so how does this work in industry? Oh, you can't. So what are we doing, folks? Why are we doing that? So our dilemma, here's the dilemma. We've been seduced by statistical systems and self-learning systems. We've been, in the last 20 years, we thought, okay, these systems are going to learn on their own. We don't need to do it. In fact, my last job, one of the VPs said right in front of me, well, we don't need syntax and semantics anymore. That's old stuff. The other part is we are lazy. We're getting to the point where we don't think we have to put anything into these things, that basically all we are coders. I call them coders, not programmers, who just put a bunch of stuff together in scripts like Python or other languages, and and voila, we can do what we need. We also have arrogance. I know when I was coming out of college in the 1980s, I was in my 20s, the same age as you. I swore I solved natural language processing by thinking and trying to come up with the right to left parser. And I said, this is solved. Of course it wasn't. But, you have this arrogance. And we think that NLP is applying generic packages to any NLP problem. That it couldn't be the furthest from the truth. And in fact, when you listen to yourself, when you try to talk about a specific application or a specific NLP system, let's just say sentiment analyzer for Cricket, which we had one of the interns from your university work on, you realize that even just for one team, you have different vocabulary and different things going on. So this idea that you're going to apply generic packages across systems is also a myth. So our choices are this. You can follow the short time hype, get your job, try to apply statistical models, not to listen to those of us in NLP for decades. The president of the Association for Computational Linguists, had a question after a talk, and the student gets up there and says, well, you know, when we're looking at how large language models reason, they don't reason. Yet we are all seduced by it. This is no different when ELIZA came out in the 1960s and early 70s, and people thought when they typed into literally a teletype machine and somebody's coming back that there were another person on the other side. So we've been seduced by that. But we can learn and understand if we learn the underlying principles of AI and NLP, the limitation of statistical systems. The current NLP toolkits are practically useless in real-world systems, and that there is a promise of rule-based systems, and that rule-based systems take work. That is, you're not going to have a system that's going to know all about some area and you just train it on text and it's just going to, you know, do stuff. It doesn't happen. And that every NLP task is unique and requires unique coding. That's the way it is. Okay, and let me give you some real world failures in my own experience. Radiology reports in my last job, they hired 2 NLP ML PhD students, worked over a year. Best results for about 60 to 7% reading these radiology reports, and had to come back with links of problems, like 6,000 or 7,000 links. The doctors rebelled in not wanting to create training systems and didn't have confidence in the system. And the 2 young PhD students privately complained to me that all they did for the last year were manipulate equations, and they didn't do NLP. They were interested in natural language processing. They were interested in how do we understand language, and that's not what they did. And so, just stop. Not there. Another one is just entity extraction in general. It's not solved. There are human beings in 2024 and billion-dollar companies that are still sitting in front of computers extracting information or adding codes to text. Medical coders, which you can be is a profession which it takes about 6 months to 9 months to really train for, and the manuals literally are, if you stack them up, are almost as tall as you are. Once you're trained, you're generating an error rate of 50%. Well, why? Because there are 40-some thousand codes right now. We're going to go up to 120,000 codes. How's a human being supposed to read medical text that they don't really understand and try to pick out those codes? This is the state of the art of extraction. But when you go in your class, grab whatever entity extractor there is. Oh, it's just and then show a little toy problem, and then knowing you can't use it. Why? Is there any solutions? Well, here today, hopefully you'll find that out. I also took a Microsoft AWS AI dashboard class, and when it got the data extraction, of course, the person had no idea who I was. I asked them, well, how do they do that? And they go, yeah, for the simple things we use regex, and for the other stuff we use statistical methods. In other words, it's useless stuff again. Good news. We are here, Amnon and myself and many other people, including people at your university, are here to resuscitate NLP and give a roadmap to the future. There is a path to trustworthy NLP. I'm going to talk about that today. And even if you are not interested in NLP and are a programmer, you should know NLP++. Why? If there's a person here that says they enjoy regex, or if I were to give them the regex program I had in 1998 that was parsing resumes and have you try to interpret it, I would imagine all of us would rather go do something else. Regex is really hard, and that certain text processing problems can only be solved in NLP++. And we're going to talk about that a little bit today, but more on Friday. I have a great example for you guys to take a look at. Okay, so the history of NLP and NLP++. Topics for today, I'm going to talk a little bit about myself, the history of NLP, history of NLP++, intelligent programming, and I will talk about specifically large language models and statistical methods versus rule-based, because that is so prominent right now. Okay, I'm David D. Hilster. I've got a bachelor's in mathematics, master's in linguistics. I did that because they didn't have any degrees in NLP or computational linguistics at all at that time. I've been in the practical side of NLP for 40 years. I'm co-author of the NLP++ with Amnon, who's here with me today. I'm also author of the VisualText interface, which is super important when writing NLP++. I am an artist. People go, oh yeah, he draws. There's a picture of my wife I drew in pencil a number of years ago, her sitting in front of me. So I am kind of a person that has a kind of a bigger vision of things in general. I lived 3 years in Brazil. I have a samba group you can see down there. I love cultural stuff and dancing and all that. I know I'm talking to people in India. Man, you guys have some awesome costumes. I know our company had some. I helped out with some of their events, and we had an Indian day, and it was just wonderful. Of course, I will say I didn't say here. I am whole plant-based. 12 years ago, I changed to whole plant-based, reversed my heart disease and allergies and all that. And of course, I love Indian food. My goodness. And of course, there's a lot of vegetarian food there. So one of my favorite foods. I am a dissident scientist. I am writing my second book with my father called The Four Universal Motions in Physics. And I am semi-retired. And my big project coming up is NLP++ and blockchain. I can say nothing about that. So that is truly amazing. Fun fact, my first computer I bought in 1978 for $780, about almost $3,800. My mom fell over, had 4K of memory, only had capital letters. The motherboard was in the keyboard, and it saved programs on a non-modified audio cassette recorder. And I have it, it still works. I think it's worth a lot more money now, but that's kind of fun for you guys. That's where I learned to program. I programmed the heck out of that. That's where I programmed my own. That's where how I fell in love with computer science. Let's talk about the NLP in general. Believe it or not, one of the true first AI programs that they thought about, or AI areas, was code breaking. During the 1940s and World War II, they actually had computers that were helping out with code breaking, and they said to themselves, wait a minute, Russian is a language, is a code. We should be able to use our code breaking techniques to code break Russian into English. Machine translation. They found out very quickly that was way harder than that. So, but that was part of the history there. Turing machine was when they started in the 50s, in the 40s and the 50s. We had the same thing going on. Yes, we think it's so great today, but you got to imagine them. They had before computers were human beings, and now you have computers doing computations human beings couldn't even do. Even in the 50s, Turing came along and said, I talked about the Turing machine, but the Turing tests as well. And he said, well, if you sit down at a teletype at the time, at a keyboard, and you have a conversation with a computer program, and you cannot distinguish it from a human being, then we've reached, a certain plateau. Machines know stuff. It's intelligent, or whatever they want to call it. I'm going to argue against that. The next big move in thing that I see in linguistics is Noam. This is really abbreviated, folks. Just don't have time. Noam Chomsky came around and said, "Oh, guess what? Language has rules and rule systems. His syntactic systems, I think, is the name of the book. He became very famous for that. He's really the father of what I call modern linguistics." In Eliza and Block's world, well, those are the same things. They were going, all these things we are thinking about ChatGPT, and we're having conversations, and we thought, AI is alive, it's alive, it's got a soul. They literally thought the same thing with Eliza. You could sit down as a Rogerian psychologist, and basically a Rogerian psychologist gives you questions back all the time. I hate my father. Well, why do you hate your father? Well, my father went there. Well, why did your father go there? And it was truly a system. But the first real intelligent programming program ever written, in my opinion, is Sherdlu, Terry Winograd from I think MIT, in the blocks world. They had a blocks world, and you could ask it questions and command it about this blocks world. It had a box, had blocks and pyramids and sizes and colors. It knew everything. And this is in the 1970s. You could type in there. It knew everything. It could answer. It could even ask why. It says, pick up the green block, and it would pick up the green wall. Why did you move the pyramid? Well, because it was on top of it. So it was literally showing that if we had a system that knew all about not just language, but the world it lives in, conceptually, it understood everything about that. Well, in the 1980s, we started with more powerful computing systems to work with. And that's when I started. That's when Amnon started. Amnon started probably a little bit in the 70s as well. We started looking at the linguistic rules that were given to us by Noam Chomsky, and we started to try to apply those. A good example, we used the Lisp language, which is basically an AI language where you can treat data as program and program as data. And then we also had the programming language Prolog. Prolog gave us the ability to write rules directly and nothing else, and it would take, and you give it English or whatever language, and it would parse it. Of course, we ran into a really big problem: combinatorics. When you have an extremely complex and long grammar written out with all the optionalities and all that, then what you end up having to do is try to map text through that space, and it became combinatorically impossible. So in the 1980s and 90s, actually, we started to get machine learning and statistical systems. You can look it up, and the first statistical systems were through there, and that was really interesting. I'm looking at this as a person who's been in NLP, what I consider landmarks in NLP. First translations came out because of the neural networks. The neural networks is a statistical system. We started having ability to do translations, and that came out in the mid or early 2000s. The reason that even existed is because Google got a hold of all the translated documents by humans and could train their systems through the State Department, if you want to know where that came from. And then in the 2010s, and there was speech recognition at that time, but it was really bad and it was really slow. No one really used it. Speech to text really started to take off in the 2010s. And then, of course, in the 2020s, we have the statistical systems out there and large language models, but I'm going to say I don't think that's going to stay around or be as useful as what I'm going to call intelligent programming. I want to tell you about my own journey, and this is also the journey of NLP++. Amnon has a little bit different journey. Got my in 1985, got my degrees. I worked in the first place I worked was Battelle Memorial Institute, invented xerography in their AI group. Believe it or not, I was hyped then. Japan was a big competitor. I actually was told I was given so many thousands of dollars more because literally my boss said, you're being hired, this is how much you get, but you're getting a hype pay because everything in AI is hyped now. But through 1985 and 1987, I learned the C programming language, and I wrote a natural language interface to SQL databases called NLQ. I sold everything, went to Brazil. I figured if I didn't do that soon, I wouldn't do it. My friend Klaus Obermeier inherited my projects, and here you can see a floppy disk right there. If you see, that's a 5¼ inch floppy disk, which I still have today. It's sitting right on my desk here, and he got an award for it. I didn't care because I wanted to go out. I was single, went to Brazil, got a visa because I was the only person in Brazil at the time who had experience in natural language processing. Got my work visa for that, and I worked on Verbo. Get this, folks, programmers. It had no hard drive, 2 5¼ inch floppy disks. One had the operating system for Lisp. The other one I wrote the programs on to do a natural language interface to a database of soccer players in Brazil. Of course, soccer's big. I then went back to the United States. I was hired to take a Lisp program written by Amnon Myers on a Lisp machine. He'll hopefully talk about that a little bit tomorrow. And to go to C++. I think it was C++, C or C++. Then later on, we participated, and Amnon actually helped organize the message understanding conferences sponsored by DARPA. And there we had preliminary parsers and NLP systems that were the preceding, kind of the same things that we did in NLP++, but it wasn't NLP++. We competed with the best people on the planet, or in the United States, people from the best universities, the best companies, and we came in 3rd place, and we were kind of accused by some people of cheating because you had to do your own tests. We had to literally take 100 terrorist texts, extract the information, put them in the database. Everybody did that. That was used by other teams, and then we ran on a blind set. Well, it turns out that we did a lot of things that other people didn't do. They saw how we did it. And the next years after DARPA, we all of a sudden saw, oh, that's interesting. They're kind of using what we're doing. Through the years, my Amnon and I moved to, I think, TRW, Space Park. And from there was a person who saw some of the work I was doing, started a company called iSearch, which was processing resumes, had the whole thing written in regex, I believe, or some other, something like that. Maybe it wasn't regex, it was Perl, perhaps. And they wanted me to come in and write this in a better system. So I did a whole rule-based system without an NLP++ language. While I was there, we basically were processing 8,000 to 10,000 resumes a day with my system. We had reviewers, an entire floor of probably about 50 or 60 reviewers. And once or twice a week, I would go up to that floor and I'd look at everybody, and they looked at me with dagger eyes because it didn't always work well. And I asked the people, why do you hate me today? And they tell me, Dave, it's always getting this wrong. So I go back to the system. And because it was a rule-based system, even though it was hard-coded rules, I could go in there and actually improve it. At that time, Amnon's family says, what do you want to do with your life? Amnon, I'd love to have an NLP company. I was at this company doing pretty well. And he lured me away, friends and family, started a company called Text Analysis International. And that's when we developed the NLP++ language, VisualText, and of course, incorporated Amnon's conceptual grammar, which he had carried with the beginning. I kind of was the person doing the rule-based system, and the VisualText editor, that was my thing. He was the person who brought the conceptual grammar and his abilities to write a language interpreter in C++. His code is absolutely amazing. You can go to NLP-engine and see it, all the C++ code there. Good luck. And it's great. 2014, we had some job. Oh, by the way, yeah, the .com crash. I said to Amnon, no one's going to pay attention to this for 20 years. Unfortunately, I was right. So I kind of went off and did other jobs. He worked at UC Irvine, I think. And then NLP Cloud in 2014, we had some companies. I implemented NLP running on NLP++ running on AWS, and we came up with NLP Cloud. You can see a logo there. I even designed for it. In 2018, I was already at LexisNexis in their supercomputing group because I showed them NLP++. They got all excited about it. And so we decided in 2018 just not to have problems. Amnon dissolved the company, and we went open source. 2022, between this time and 2022, we took the older code, got it updated so it now runs as C libraries and an executable on all three platforms. And I came up with a VS Code NLP++ language extension plugin, which is now the editor for and I would not ever try to do any editing of NLP++ without it. It's available for anybody. You can download it right away now. And then we also developed a NLP Plus package for Python. We've been trying to get it. It's been there for almost a year, trying to get approved. Oh, I think more than a year now by the Python package. They have so many but you can download it. It's in the GitHub. So if you want to run natively NLP++ analyzers using Python, that it's using the C++ libraries, you can do that. And then something, again, I can't talk about, but blockchain, that's going to be pretty amazing. Okay, so the 5 linguistic revolutions. This is my own thesis, so don't take this as everybody believes it. I just did it myself. First was writing systems. Writing systems were really important. People spoke for a long time, but they started to write it down. And writing systems are called orthographic systems. That's what we call it. Next one I think was very important was the printing press. It basically took those writing systems and allowed everybody to use knowledge. Of course, knowledge and writing are very much intertwined. So that is something I'm going to talk about as well in a little bit later. The next one was the dictionary. Now, why the dictionary? Well, the unabridged dictionary is the first time we really sat down, looked at a language, and said, what are the meanings of these words? Where did they come from? So it was really the first time we started to categorize the meaning of things. Fourth revolution, of course, I've talked to you guys already about, is Noam Chomsky, language was rule-based. It isn't statistical. Language is not statistical. Those of you who think large language models have understanding, it's not. We human beings do not use statistics, very rarely. And the only time we use statistics is when we go down garden path sentences that go the wrong way because we hear words like prime number together, like the sentence, the prime number few, the prime number few, the prime number few. 4 words. It's a complete grammatical sentence. Most people can't get it because they think prime number, they go down that garden path, that statistical side, that they put those two together and they can't get away from that, not remembering that number is a verb and prime is a noun. So that the sentence, the prime number few, mean the great people, there's not many of them. So that's only one of the very rare times that our brains use statistics and get us to it. Those are wrong. All the rules. If I give you 10 sentences, every English speaker, we all have different neural networks in our brains. I give you 10 sentences, and some of those are not part of the English language. Everyone will get it right. All the English speakers will get it right. Wow. Not statistics, because we all have different brain neural nets. So that's interesting. So I call the next revolution NLP++. Now you're going to say, that's really, oh, great, Dave. Of course, you invented it. So there you go. How arrogant can you be? But the truth is that we have to put knowledge into computers. We've taken knowledge and put it to the masses. We know that there's structure to it. Well, we've got dictionaries and all that about meanings of words. The only way we're going to get computers to use natural language is to give them things like dictionaries. I'm going to talk about that. You're going to go, well, Dave, then you don't need that. Yes, we do. Shock. English doesn't have a good dictionary. Chinese has 0 dictionary. That's linguistic. Go to Wiktionary. I had a student from Stanford worked for 12 months, and he was literally almost crying at the end of those 12 months because he said, there's no Chinese dictionaries out there. He found one small one for what? A gaming system Chinese guy wrote. So this has to be done. You can't get around it. The 5th revolution is a manual process. Passing knowledge to computers is a manual process. We can't do it any other way. It's the way human beings learn. You tell me how you learned how all the words that you did you just stare at? Well, we'll talk about it. I'll get ahead of myself. Language is arbitrary. The written language is arbitrary. You can't tell, and I will talk a little bit more. We have become lazy and AI used to training computers, so yeah, that's the way it's going to be happening. It has to be that way. But no, we must construct knowledge to pass computers. NLP++ is the first computing language. It's the first, kind of like the printing press for computers. It allows us all to work in the same language. Anybody with a text editor who's not even an NLP, who's not even a linguist, who's not even a computer programmer can develop dictionaries for NLP++. Very easy to do. So let me give you some examples of why we have to give it to them. Well, here's a good one. 3100 BC, writing system, hieroglyphics. The best human minds on planet Earth for 1,500 years couldn't decipher it. It's arbitrary. How can we? There's no way. So we found the Rosetta Stone, which happened to be at a time where they were making an announcement in this area, and they put these everywhere, and they had these 3 languages, and now we could interpret it. But it still took till 1822 to be fully deciphered. So orthographic systems are arbitrary. They usually start out with pictograms, and they slowly get more arbitrary, and they have to be memorized. Period. I remember coming home crying at 6 years old because I had to go to skip kindergarten, go to 1st grade, and everybody's reading. I wasn't, so I got my first book, and that's the first time I saw words, and I started associating them with things. That's memorized. We must manually. That's why we have to give them computers. They don't know. Here's a good example. A large language model can train on all the Chinese in the world. It can simulate conversations statistically. That's all it's doing. I'll talk a little bit about a good analogy for that is. It will never be able to statistically identify the characters that mean mother. Here's Chinese text. Where are the characters that mean mother? And how is it going to find it? By cleverly doing statistics on it. It's not. For those who want to know, there it is. Those, I don't know, some of you may speak Chinese. So human language takes 4 to 14 years to learn. Okay, let's all agree that the human brain is the best neural network, at least for doing intelligent stuff right now. Okay, let's just say that. Yeah, it's constructed differently, but it takes 4 to 14 years to learn a language. What's the easiest language to learn? English. So if anybody says English is hard, it's a lie. What's one of the harder language? Takes 14 years. It's considered to be an adult language. A linguist considered to be adult speaker of that language is 14 years. Finnish. Why is Finnish so hard? Because they have long and short vowels and consonants. So if you, depending on how, mak, those are all different words. It's crazy. It's kind of like Chinese, but even worse. Mandarin Chinese, one of the hard ones too. Computers must be taught language as well. I'm sorry. So instead of this Turing test, I'm going to be arrogant here and say we need to do an intelligence test, and that's different. And what is the intelligence test? This was from a lecture I gave at Clemson a few years ago. And that is humans must be shown that a computer has understood text in the same way as humans understand it. This creates trust. This is why we don't trust ChatGPT, because we know down in the bowels of that program, it's not understanding anything. It looks like it is, but it's not. So instead of just having someone type out, if we were to put the Turing test to ChatGPT, the Turing test says, hey, it's intelligent. It's that computer program. It's that AI thing we're looking for. No, it's not. Because when we ask it to explain itself, it doesn't explain itself because it doesn't know what it's saying. And the explanations are just statistical outputs from explanations it's already seen. I'll tell you what my analogy to that is. So it involves linguistic knowledge, memory, world knowledge, etc. So I think that's what the intelligence test is. And that's how we trust it. When I did the radiology, remember I talked about the radiology? I did a prototype in 2 weeks with NLP++. I showed the doctor how it was coming up with what he goes. He goes, wait a minute. It's doing exactly how I do it. I go, bingo. And I said, the reason we can do it is because NLP++, the cognitive model that Amnon and I based it on, allows us to do that, to take whatever knowledge human beings have of language and use it. And that's what NLP++ is all about. So intelligence, language and intelligence have evolved over the thousands of years together. Knowledge and language intelligence are almost inseparable. We couldn't be talking the way we're talking about conceptually and all these things if we didn't have language. Just forget it. It just wouldn't happen. Certain things we can do. We can learn how to build houses. We don't need to talk to each other about that. But if we're going to talk about, what empty space is versus something in space, or concept of happiness or whatever, those kinds of things, it's really hard for us to talk about philosophy or even mathematics, all these kinds of things without using language. So think of today's world. Would it be possible with language? Of course not. In intelligence required understanding language and the world it represents. What's the purpose of language? Well, I've got something in my brain, and I want to say it to you. We have a system we've all learned. Words mean something. They're just not signals. You don't have a, and when I have a picture in my brain, I then translate. Oh, I see John. He's a soccer player. And I see he's a goalie and he saved the goal. And so I say the words, John saved the goal. And that's the way we communicate in the stream of words and information. It goes into your brain. Your brain knows how that language works, knows that, oh, John is a person, saved the goal, oh, must be a goalie. And I probably know John. I have a model of that in my head, and that's what language is about. I have something in my head. I use it to communicate, to try to get that same thing into your head. Simple. Well, again, I talked about this already. I'm sorry. But again, this is the shared blue. You can see here, pick up a big red block. Okay, grasp a pyramid. I don't understand which pyramid you mean. Wow, it is. It's intelligent. This program is intelligent. It understands this little block world just like a human. This is the same way we humans do it. So Terry Winograd, he did this way back. We're not doing it today. So this took me 2 months to come up with these words, both for intelligent programming. I said, how can I distinguish programming with NLP++ with traditional programming? And I couldn't come up, go Google what is the definition of traditional programming. It is so hard. There's just nothing out there. I spent months and I said, okay, how can I come up with a way? And it really helped me to understand traditional programming versus intelligent programming because of the intelligent programming side. So I came up with the few words that we need to describe intelligent programming versus traditional programming. So what is traditional programming? This is Dave D. Hilster's definition, the smallest I could come up. You think like a computer. That is, everybody who's in this right now is probably in computer science, knows how to program computers. You're all, many of your friends, most of them, some of them, some of your friends, a lot of your family probably have no idea how to program anything. And so what makes you a programmer? Because I know SQL, I know Java, I know Python, I know Delphi, C++, Perl, TypeScript, Ruby, R, all of these things. And that's what makes me a computer programmer. So if I think like what makes me a good programmer is because I think like a computer. NLP++ is very different. Intelligent programming is thinking like a human. When I had one of my students from your university, he was working on the sentiment analyzer for cricket games, and we were talking about it. He was in an NLP++, and he was in a while loop, and he was going in, he's saying this while loop, and blah, 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 and I stood back and said, wait a minute, what are you trying to do? He says, well, I'm trying to make a loop that goes, I know. What are you trying to do? Well, I said, think like a human. What is this code trying to do? And he goes, oh, he stepped back and he goes, oh, I think I do it like this. And I go, yeah. So what does this loop say? Well, that's not the way we do it. I said, yeah. So he went back and he started, and it was funny because he came back to me the next week, goes, you know, Mr. Hilster, I don't want to say this, but all these other computer programming languages I've learned and I know, they're just not as fun as NLP++, because you have to think like what humans do. And I never thought that way. And that's the biggest thing. When I talk to people about NLP++, when I'm giving I have mentoring interns, I say, there's two rules to NLP++. The first one is think like a human. The second one is think like a human. And they go, why do you do that? I said, if you ever watch the Fight Club, which is a movie, one of the things about the Fight Club was about a fighting club that no one's supposed to know about, and you're not supposed to talk about it. And when you went to the Fight Club, very famous line from that movie, it says, first rule of the Fight Club, don't talk about the Fight Club. Second rule of the Fight Club, don't talk about the Fight Club. What does that mean? That's the most important thing. So the same thing with NLP++. You got to think like a human. Well, it is intelligent programming. Basically, how did that happen? Well, in 1998, Amnon and myself invented our dream programming language for NLP++, or NLP. And it was based on a simple cognitive model. And that is, people have words, tokens. Sometimes you can, in NLP++, you can break up even words into letters if you want, emojis, whatever it is. And we have tree structures. We know this because we form things. When we see a date, we have a tree structure in our head. You can say you don't, you do. There's a month, comma, date, comma, year, those kinds of things. And actual language has many of the same attributes. So you have to have a tree system and a tokenizer. Then we have to have rules to match, because we have, simple rules. When you see a word that can be a month, date, or year, a month, then okay, then you got a number right after that can be in the range of a day in a month, in that month, and you can match and you can build trees with. So you can have these rules. And NLP++ has the most sophisticated rule system out there for natural language. And there's a knowledge-based system, the conceptual grammar. That is, when you're doing things and you're reading, you have concepts in your head. Amnon has a Vox system, which he showed me a paper from way back just this week. I think this was last week. And I was looking at it. It is amazing, the way he parsed just the sentence. The guy is very brilliant. And NLP++ programming language with the tree and the KB functions is what we came up with. It freed the program to concentrate on the NLP problem, not the code. Another one story real quick from the some of the same projects. I did several projects with your university with interns. And one of them came to me I think 4 weeks into the 12-week internship. And he says, David, Mr. Hilster, I just want to say, I want to tell you a story. So this week we decided to stop the project and say, okay, can we do this project of reading Wiktionary pages, English Wiktionary pages, which has definitions of English. They're using NLP++ to read the dictionary of English, which is really hard, folks. If you go there and you try to write a rule-based regex, forget it. So they said, okay, can we do the process of just reading these Wikimedia pages for Wiktionary using whatever other language? And they said within 20 minutes, they realized it was impossible to do without NLP++. Impossible. And as Amnon has said many times, yeah, you can do it, but you're going to have to come up with a tree system. You have to have a rule system. You have to have knowledge base. You're going to have them all interact. It already exists. So That's there. So if you look at this, it is kind of a paradigm shifting. If you look at Python, for instance, you got Python, and you got your part of speech taggers and your ML and deep learning and neural networks, and you have your ontologies, you have a text zoner and all these things, but you have no custom syntactic tree, you have no KB, live KB that you can build as you're reading text, which is really important. As I read and I say, Dave D. Hilster is giving a talk today. He plans to talk on blah, blah, blah. How do we know what he means? Those kinds of things. Well, I've got a package for it. It doesn't work. We'll talk about how that doesn't work either. So there's no standard for the KB. There's no standard for the dictionaries. There's nothing there. And so if you look at what we have text in the tree structures, and we have the knowledge base, and then we have the NLP++. If you look on the right-hand side here, you see NLP++ in the middle. We have a syntactic parse. We have the KB from the parse text that we build. We have linguistic and world knowledge, which includes dictionaries, and all of those can interact at any level. It's one of the problems with NLP systems, even like core NLP. They're siloed. They're built by grad students. Okay, you've done the tokenizer. I'm going to do the syntactic parser. Well, what happens when the semantics changes the syntax? It happens. Well, NLP++ allows you to deal with that. Okay, so you have the NLP++ programming language, visual text, very important, and the conceptual grammar. NLP++ is unique, allows for concentrating, like I said, on the task, intelligent task, automatically breaks down text into tokens. We have various tokenizers, handles all the text, including Unicode emojis. Believe it or not, if you look over on this side, you can see a rule I wrote just for fun. An underscore emoji with the heart eyes is, if you find these two emoji, you can rewrite it to this concept of this emoji. This underscore means it's a concept. You can use this stuff. It's quite amazing. Unicode, it was one of the biggest and hardest problems I've ever done in programming, to get the NLP engine using Unicode. It uses the ICU C++ package. Sophisticated rules and functions. The functions deal with the knowledge base. You can have the tree point to the knowledge base. You can write things to go through it got dictionaries, all that stuff. The knowledge can be built on the fly, and it's highly interconnected, and the visual part of it is very important with visual text. Visual text is very important. Why? Because there's two things that the human brain is a neural network. It does great at recognizes faces, which is really hard logically. It's almost impossible logically. And it's terrible at math, and it's terrible at language. Language has to be taught. The only reason we learn it is because we're around it so often, and we learn it. But it takes us 4 to 14 years to learn it. So we are visual creatures, and for us to build something complicated that's parsing through language a step at a time with the syntax and the parse trees and the dictionary and the knowledge base, well, visual text has all that. You have your text up here, you have your analyzer sequence, which has all the rules and stuff in NLP++. You have output that you're building as you go. Here are like one that I built for sentences and all the things that are interesting I find in the sentence. Here's the syntactic tree. It's all visual. In fact, it was really interesting. The first person to use NLP++ in a master's degree at Clemson, he said that if it wasn't for visual text, he couldn't have analyzed, because you can use visual text to take lots and lots and lots and lots of text and write rules and do corpus studies. He says, I couldn't even write the NLP++ parser to look at code and then try to put codes on it like human coders do for medical coding if I didn't have NLP. He wrote 60 NLP++ analyzers. Everybody should know this language. Everybody. If you deal with text, you should know this. Here's a knowledge base. Why do you need a knowledge base? Well, here's one. As we're looking at the radiology text, and it says, oh, the appendix wall thickness is 4 millimeters. Well, here are a bunch of different languages that say the same thing. And why would you want NLP++ to be able to get that information? Well, it turns out if you have a knowledge base along with this NLP++ parser, and it compares it to what's considered the organ and its normalized size, oh, it says that the walls must be 3 millimeters or less. And this is programming, folks. It isn't neural networks, it's programming. And you say, just go look at any value that's out of the range. And then I can go and show them a link to an appendix. This was the problem that was offered to us in my job where I worked before. And when I showed the radiologist goes, yeah, this is what we do. So it allows you. That's why knowledge bases are important. Here's just a good example of something I gave a talk on. This was looking at indictment articles and trying to get out who was indicted, because computer companies that have databases of all the people, they want to know if you have been indicted for a crime, because then the companies that use a database of people are going to say, I'm not going to give you a loan if you're a person indicted for money laundering, for instance. But the problem is you read here in the first paragraphs that are usually general, it says a St. Louis residence, his, that's all you know. Who is it? Well, later on you have the person was in an indictment. So I'm building a parser, just a demo parser that said, okay, I'm looking at indictments, parsed the sentence and found that there was a St. Louis person that was being indicted in the first paragraph. Second one, it says that this person was charged with these things, and you end up with a profile of a person that's spread across text. NLP++ can do this. It's called it's anaphora, what we call in linguistics. It's something that points to something else. So the St. Louis resident is him, and his role gives us male. So we get Batunda Taiwo. He's a male from St. Louis, and here's the indictments. How do we get this? Look at this information. We can get it, and there's a video on that parser if you want to take a look at it. Of course, everyone hates regex, and NLP++ should be in everybody's toolkit. And if you enjoy this syntax, more power to you. But come back to it 2 years later, it's really hard. So, and the NLP.exe runs on all three platforms. It's called by the supercomputer. That's from one of my slides when I used to work for the HPC Systems supercomputing system. And then the NLP engine is in C++ and compiled in any language compatible. And you can go get the NLP++ package. It runs it natively. And if you load in the analyzer and the dictionaries and all that for whatever analyzer you're running, it will stay in memory and run it in a loop in the middle of Python. So that's called we call that NLP+. It's still trying to be approved after a year for Python. But okay, let's talk a little bit. I'm going to end up talking now about large language models and statistical methods versus the rule-based system. Just wanted to touch on this because so many people are doing this right now. So many people are out there starting jobs, starting companies around large language models. Those of us who know this and know what it really is, have been around a couple of decades, we are predicting a large language model crash in the next couple coming years. So this is, if you want to explain, I came up with this myself. I think this is a wonderful, wonderful way to explain like ChatGPT to the average person, or even people who are computer programmers who have been seduced that these things are actually learn or anything. So the way I describe people, I said, they go, yeah, ChatGPT, it doesn't seem to, I mean, it works for a while, then it kind of goes weird. I said, well, think of it, ChatGPT doesn't understand any say. ChatGPT basically is just a village idiot. And they go, what do you mean? Well, the village idiot stands in the village square listening to all conversations of everyone. Lawyers, doctors, mathematicians, actors, etc. All of those people. And they learn to talk like everyone. And so you go up to them and they can converse. They can ask questions and explain their answer. You can go up there and say, I've got this elbow problem. Well, we probably have this, but they can even say things, but they weren't trained on it. They don't know what they're saying. Yeah, you can take this medicine. Well, yeah, they've just learned to talk like them. Do they understand? If they give something new, if they came up and pointed to their heel and they've never heard about the heel, they could, maybe talk about something close. And that's exactly what ChatGPT does. If you talk about something very specific that it has no idea, it will, and then when you say, then you teach and it goes, oh, I can repeat that, but that's all prompt. So that's what a village idiot does. They answer questions. They can explain their answers at times, or it seems that they do, but they don't understand anything except how to talk. That's all it is. Think of it this way. If you take in a large language model and you train it on Chinese, you don't speak Chinese at all. You give it to some other person and they're querying it. They'll be maybe fooled that thing's understanding everything. They're not understanding anything. The program doesn't go out. It doesn't know what any of those symbols mean, just as much as you don't. Okay, so I think that's good. Here's the the shrews, large language models. They do not reason. They do not understand. They do not remember. In fact, the way people do it is, oh, they got these terms in large. I don't even want to learn them. Reg or something, or rag. Oh, and I looked at it, I thought, oh, this must be really some amazing thing. No, it's just pumping prompts from before and doing. It's like, this is computer science. This is trying to understand how human beings understand language. This is sad. This is really sad. And so they don't remember. I had a conversation with it about the 4 universal motions. My father and I was working on the book, and they gave it like, rotation, linear, and all. I said, no, that's not what we say in our book. We say blah, blah, blah. And they come back and say, oh, you say blah, blah, blah. Right after that, he says, explain those again. Didn't know. It went right back to what it said before. I just said I didn't have any connection to the view. So they don't learn. They don't explain. Well, I've seen them explain math problems perfectly well. Why? You know how many math explanations in videos, which have been translated into the native languages, that these things have trained on? An immense amount. Of course, they're going to get the patterns. If you have a human being with a kind of almost infinite memory that can listen to this all day long, they may not understand a word that people are saying, but they could explain these things. So people are fooled by all these things, but there's no understanding that. They mimic all these things from seeing these types of texts. They do not have a notion of even the type of thing that they are saying. We have to prompt it to do those kinds of things. We have to train it on certain things so that when a person talks to it, oh, well, it's just got to be trained on, words come out, and words still come out one at a time based on probability. And human language is not based on probability. It's based on rules, period. It doesn't. The only time we use, it's not like when I say Google, in your brain, you go, well, Google is 73% it's used as a verb, and 27% of the time it's used as a noun. So I'm going to use it as this. No. We have all kinds of stuff going in our brains, and we've shown linguistic tests, psycholinguistic it's called, where they show people have rules in their heads, even though they don't know they have rules in their heads. So why do people continue? Well, they don't understand that LLMs are statistical and all the problems with it. They don't understand it. They get psyched out. They're in love. They think they found it. They think the answer is here. People are scared. The public was scared when LLMs came out that the AI was taking over. The public, believe me, I lived through it. The public was scared when the lies that came out in the late 60s and early 70s, saying everybody says, oh, computers are taking over the world. It's the singularity has come every 10 months. I mean, every 10 years. I have an article you can read on, just Google it, singularity, David Hilster. And they get fooled by the village idiot, basically, it's doing this, it's really understanding. How can I get it to be less biased? It's like, or how can I get it to reason this way? These are, no offense, the wrong questions. These are not real things. You can't do it. It's like saying, how can I get a hippopotamus to fly with its current way the hippopotamus is constructed? Yeah, it's going to fly. Yeah, I'm sure. We'll get it to fly. Pigs fly, I guess. Arrogance is another one. I've seen these young people who are involved with OpenAI. I mean, the arrogance is stunning. I mean, it's stunning. I just look at them and shake my head. It says, these are the people we're trying to, that we're teaching. That's why I'm here today talking to you guys. I don't want you to be that. And I've found that the students from your university are very open to this. And a lot of people have already come to these conclusions. The other one's money. When I stopped working at LexisNexis, I was looking around just to see kind of things, because I was looking into, semi-retirement. They had jobs for $500,000 a year if you could come to the company and start putting LLMs in. I was in a company where they said, we want to use this other type of NLP, not the NLP++. And I said, I'm just not interested because it's not going to work. But people don't know that. So money, of course, will show up. So I'm trying to get you guys to think about this. So the real world failure example number 4, I've saved here till last. I'm finishing up here. Is an actual lecture. You can go look at it. If you look on our NLP VisualText NLP++ YouTube channel, there's a presentation by Guilherme, and he works at LexisNexis. He saw a talk I did in Portuguese for the team at LexisNexis in Brazil. They liked it, and they had an address cleaner for Portuguese, which is a real common one. Everyone around the world uses. It does it for lots of languages. And LexisNexis uses this off-the-shelf address parser. It's a black box, it's statistical, and the statistical mistakes are not logical. You cannot fix them with logic. So he was having the problem. He says, look, it's coming up these real weird errors. And, he looked at them and tried to classify. He could find maybe 15% of them that had some kind of pattern. And so he would go and write some just one-off code to go and fix that. But after a while, he's looking at it, he goes, this is so simple. Why it's not getting this, I don't know. Because when I look at this address as a human being, it's really easy. Well, they saw the NLP++ talk I gave. And so he says, Dave, I want to do this. So he was given 30% of his time. I actually came up with dictionaries. If you right-click in the KB window of NLP++ VS Code, if you download it right now, right-click, you'll see Portuguese. You go to languages, Portuguese, you'll see a bunch of things that have dictionaries for roads and dictionaries for all kinds of human names, even all these kinds of things that I actually helped build. And how did I build the knowledge that's used by NLP++? I built NLP++ parsers because we humans do that. So I go to a web page, build an NLP++ parser to go through the web page and build a dictionary that NLP++ can use. So it's a bootstrapping system. So they built a Portuguese language parser. If you watch I highly recommend watching his presentation. It's not that long. And you can see the shockingly good results he got with really very little work. And of course, when there's a problem, it can fix it in a logical way. The system can explain, why it did what it did. And that's the number one thing about this technology and why universities are looking at this much more seriously to do true NLP understanding and in systems that will make decisions that are going to be very critical, and you can't do it with statistics. So some of the misunderstandings about NLP++, we've been asked this a lot. Oh, NLP+ rule-based can fix LLMs or their statistical mistakes. Statistical mistakes are not logical errors. Statistical mistakes are not logical errors. Think about it. There's no logic to it. They're probability. You can't go back and look at, you can't even categorize it. No offense, you'd be insane to pretend you knew. So that's really important. And then to correct problems and errors in the Brazilian address parser, you look at it and you go, well, the reason it has this, obviously these two numbers are Brazilian zip codes. Obviously they're the same number repeated in this position. So obviously this is just a repeat. So yeah, but how do you figure that out? You can't just go into it. If you just take two numbers that could be zip codes, well, it could be a number of address. So what do you end up doing? You'd have to recreate an entire Brazilian address parser to be able to fix the black box system. So why use the black box system? I even had a professor at a university, which I will not say, oh yeah, we can use this to fix this machine learning stuff. And then I ended up explaining this and they go, you're right. You'd have to write the whole parser. I said, yeah, and if you have it in a rule-based system that's a glass box, NLP++ is a glass box, and you're good. So NLP++ can generate example for statistical systems to train. Okay, that's great. No, generating more data to train on does not solve the problem with statistical systems. That's what people are. Believe it or not, I actually applied for it just because I was so curious. When I stopped my last job and semi-retired, I was looking for, well, what's out there? It's like, companies are hiring human experts to generate. In fact, I got a job offer to just do math problems for a company that's generating math texts and answers so it can train their systems on it. You're not going to get away from the problem. You're not going to get away from the system erring, and then the person who you get hired by a company that's using large language models, statistical systems to do math problems, and the boss comes back and says, hey, it's getting this math problem, fix it. What do? Well, I'll try to make more examples like it. But can you go back to your boss and say, 100% guaranteed I fix that problem? With NLP++, you know exactly what it's doing. In fact, you can correct the problem in a generic way because our brains, what is the difference between NLP++ and a statistical system? Statistical systems come up with nodes, and neurons come up with nodes by themselves, and you don't know what they are, or even if they're right or if they're useful, because it can do the whatever it wants. Well, what we do is program with NLP++. We don't need to develop on 10 million documents. We can take 20. Why? Because our brains, our human brains can generalize. We have the ability, we have the ability to generalize. So when I write a parser for radiology reports, I don't write it with these 4 words and it can never do anything else. You use your so the training gets replaced by the ability for the human programmer to generalize and encode that. I should make a slide about that. That's pretty, said that before. So the conclusions are statistical systems will never be trustworthy or understand anything. If you're still thinking that, then I'm sorry. Think about it more, I would say to you. Computers must be given human knowledge, just like children. It's arbitrary. Human knowledge and language are arbitrary. This idea that if we get like a language from an alien civilization, we'll never understand it, ever. They'll have things in their world that we don't even know what they are. How can we know? We can't. That's a good example of how that's what computers see. They just see symbols. NLP++ is the common computer language we can use for computers to truly understand and learn. Yes, it can. We can build the systems like the blocks world for whatever purpose, whatever process. And yes, it's going to have we're going to have dictionaries have to be built by hand. That's another project. That's why we have the Natural Language Understanding Global Initiative. This is a manual process. NLP++ can bootstrap itself. I do it all the time. And other people do it all the time. Use NLP++. You go and read something, gather it. We could have an NLP++ agent that is all written code. It's not trained, but goes and gets information about cars, reads all this text, and keeps building more information about cars. Yes, you can do that, but you do it with an intelligent way, and the system can show you how it's doing that. So NLP++ is a bootstrapping system. And I started the Natural Language Understanding Global Initiative, which we have we're starting to have memorandums of understanding, and I'd love to have that with this group because we have some pretty exciting things that we can do. So I have a very fun thing. You are the first people in the world to, except for Amnon, myself, and one other person who are working on a blockchain project. But this is the first time I am officially announcing it anywhere. If you go to fix.nluglobe.org, there is of something that you can look on your phone. We are going to, in 2025, make a big blitz on NLP++ as a language, that computer programming language. Has 3 types of analyzers there. One that would replace regex, showing how much better it is. One that does something that we all look at, which is like text that's been formatted and then just shot out in ASCII. Something is really impossible to do. NLP++ can do it. And then the third one being looking at NAFRA or something very common. Why you should all have this language in your back pocket. So you can you can literally go on your phone, click around, look at it. It doesn't run, because the idea is just to show people in 30 seconds to get them interested in it. So take a look at that. On Friday, I will be going over those 3 in kind of detail and showing you those, and you can download. In fact, if you go to that and you click on the try button after you see it, I watched the little intro video I have there, and then there's a try button. If you go to that, I have a video on how you can download those 3 analyzers as part of the NLP++. It's there. And I'll tell you how to download, put them in an area where you can play with them and all that. But that's kind of your homework assignment. If you have a phone right now, you can go there and you can literally look at it and browse all of NLP++. It is just a display. It's not a functioning. It's not functioning. So tomorrow we're going to be having Amnon talk about compilers and he was asked to talk about compilers, but he's going to talk about the NLP++ language. How many people in your lifetime, and probably short lifetime, maybe some people are here that have been around a while, have you ever met a person who's written a computer programming language? I never had until I got to LexisNexis, and I've been 40 years, met one person. So you were talking to two people who came up with a programming language, and part of that is to come up with the NLP engine that does the interpretation of it. Really fascinating about NLP++, here's a little tidbit. There's a small grammar that has to be present in the NLP++ engine area that it reads in to parse NLP++. So it's got a subset of NLP++, literally written in ASCII, that is used to do the interpretation and parsing of the NLP++ language. It also does compile to C++. So Amnon will be talking about that. So I'm going to stop my sharing here and open it up to if people have any questions. We'll open up the chat. I think people can also talk on this as well. So I don't know how many people are left. 21 people actually stayed around. So we are recording this. So do people have any questions? We have messages to everyone, or if you are there who want to come up and actually talk or whatever. So no questions. So any rule-based patterns, NLP++ will notice it. I'm not sure what you mean by that. Let me see about that. Oh, I got the wrong window open. So it's all just linguistic heuristics. Okay. So it's all just linguistic heuristics. No, not at all. I don't. If you're talking about NLP++, NLP++ can encodify any type of natural language processing you want. Any type. Right to left, rule-based, knowledge-based. Amnon has a system. It could be all done in that. So NLP++ is just a cognitive system where you can build any type of NLP you want in it. So you can even incorporate neural networks if for some reason you want to do that in that. Is Zipf's law a coincidence then? I'm not sure. Do you know what Zipf's law is, Amnon? I'd have to look that up.
Not offhand.
Okay. That's okay. So any rule-based patterns, NLP++ will notice it. No, NLP++ doesn't go in and you write rules. You can actually, it does write rules on its own. You can sweep along some text anywhere in the processing. NLP++, we'll talk about it on Friday, is basically a island-driven sequential, it's like a pipeline. It's a pipeline, starts with tokenization and goes all the way down. The thing is that you have like a whiteboard area called the knowledge base, which you can use, and you can then use that as your parsing later on. And that's how it gets rid of the combinatorics. It doesn't have these rules and then it goes like Prolog and then tries to match everything. Everything must be described like a compiler language. No. A human language most likely doesn't have, it does have bigger, but humans, I think, do things more in small localized areas and build bigger structures as they go. I think we have a tendency in our brains to be listening to phrases. As each phrase comes, we are building conceptual concepts as we go. Languages are rule-based, and NLP++ uses rules actually understand how language works. I was wondering if we could use it for, say, proving a script is a language, if that makes an Indus Valley script. Oh, no, that I think what you're talking more about statistics, really. You can use statistics to generate rules that could then be used in NLP++, but no, it's NLP++ is not to do. You can use it for corpus study, and a lot of people use it for corpus study. Like a lot of people have used it for corpus study. Not tons of people, because most people don't know about it yet. But that's what you can use it for. It's not going to give you any statistical insights. You would run statistics on it and see these kinds of patterns and all that stuff. But one of the things that is very good, and I use it all the time, I call it cherry picking. When I am doing an analyzer on text and I'm writing a rule for some construct that I see for this particular thing. Let's say it's medical text. I want to see, is this a common rule? I wrote one for a different one. I can't talk about it. It's proprietary, and it was reading these very short things, and we had all these examples. I said, how many times do people say this? Well, you can use and write NLP++ parsers to go through lots of text and do statistics on it. You know, and NLP++ is, it's like, you got to remember, humans looking at text and doing things means anything. It can mean looking through text of a web page and building a dictionary for NLP++. It can mean going through 1,000 texts to see if these patterns are, look, it's really nice because you can't think of all the patterns in English that are like this. You may have like 6 different words that could be in this place. You may need a dictionary to do that. You have to make a more complex rule to go and search that text that you're looking at to see if you find patterns in other languages. That is very useful. And NLP++ as a corpus study, nothing better, because you can go and you can write these just like a human. Okay, it'd be nice because I know these types of phrases. Well, describe what that type of phrase is. Well, it has these words, and you can make a little dictionary for those words, even if they're just variations. You don't need a whole English dictionary. We have a whole English dictionary. We have Hindi words for names in Hindi. They're already there. But the thing is and we continue to build them. So yeah, that's what I would say about that. I found that alien language scenario you mentioned quite interesting. Is there absolutely no way to gather any sense from the foreign scripts if there were minimal amounts of labeling? You know, the only way would be like the Rosetta Stone. If we got like an alien text from somewhere and then they had like pictures with it and they had something under the picture and they were simple labels or something like that, and we found those labels, we could start to do some things, but very little. It's very little. Language is arbitrary. I mean, orthographic systems are arbitrary. So yeah, you can't do that. You can't link certain words because you don't have, someone's going to have to look. We had 1,500 years with hieroglyphics, 0. And we knew Egyptians. We knew what they had. We had pictographs. It turns out the pictographs, a lot of them were phonetic. There's no way you can get that. There's just no way. So, okay. All right. So it makes sense. Yeah, I think I see it now. Okay, cool. All right. Any other questions before we go? I know it's down to 11 people now. But again, this is recorded so people miss it. Make sure you sign up for tomorrow. We'll be back about the same time. I'm going to stop the recording right now so that will be available. So if you came in later, we can do that. So I'll stop the recording.